Hi, in this video we will have a quick recap on the internal structure of an atom before looking at how to work out the electron arrangements inside atoms, and finally we will have a look at how the electron arrangement determines the position of an element in the periodic table. The diagram on screen shows an outline of the internal structure of an atom. Now recall that the nucleus is at the centre of the atom and it contains positively charged protons and neutrons, which of course are neutral and have no charge. Now the electrons are arranged in electron shells or energy levels which surround the nucleus. In the diagram shown, there are three energy levels or electron shells. The electron shell closest to the nucleus is the one lowest in energy, and it can hold a maximum of 2 electrons, while the second and third energy levels can hold up to a maximum of 8 electrons. Now remember that in your GCSE course, you only need to be able to work out the electron arrangement for the first 20 elements in the periodic table, that is up to element number 20, calcium. So let's have a go at working out the electron arrangement for the element magnesium. Now in the periodic table, the chemical symbol for the element magnesium is Mg, and there are two numbers beside the chemical symbol. These are the numbers 12 and 24. The smallest of these two numbers is the atomic number, and this tells us that there are 12 protons inside the nucleus of a magnesium atom. However, in an atom, the number of protons is the same as the number of electrons, so this means that we also have 12 electrons present in the electron shells or energy levels in the magnesium atom. So now, all we have to do is to decide where to put the 12 electrons in the electron shells. Remember that the first shell can hold a maximum of 2 electrons, and the second shell can hold up to a maximum of 8 electrons. Now to fill the second shell, add the electrons one at a time in a clockwise manner, starting at the 12 o'clock position, and then the next electron at the 3 o'clock position, and then the next one at 6 o'clock, and finally one at 9 o'clock position. If you need to add more electrons, which in this case we do, then start again at the 12 o'clock position and add the electrons at the 3, 6 and 9 o'clock position until the second shell is full. With the 2 electrons in the first shell and 8 electrons in the second shell, we have placed a total of 10 out of the 12 electrons present in the magnesium atom. This leaves 2 electrons to go into the third shell or energy level. Now remember, the electrons are negatively charged and so will repel each other. So put these 2 electrons as far apart as possible in the third shell. We now have 2 electrons in the first shell, 8 electrons in the second shell, and 2 electrons in the third shell or energy level. This means we have an electron arrangement of 282 for the magnesium atom. Now, just to finish off the atomic structure diagram for magnesium, let's add the neutrons present in the nucleus. To calculate the number of neutrons, you simply subtract the atomic number away from the mass number. In this case, that is 24 minus 12, which will give us 12 neutrons to place inside the nucleus. In the periodic table, the elements are arranged in vertical columns called groups. Now there are 8 groups, starting with group 1, the alkali metals, and ending in group 8, or group 0, the noble gases, with the transition metals shown in red in the periodic table on screen. The horizontal rows in the periodic table are called periods, and in the periodic table shown there are 7 periods. Now there is good reason why the periodic table is set out the way it is. For a moment consider the element magnesium. Now its electron arrangement was 282. Now the magnesium atom has 2 electrons in its outer shell or energy level, and it has 3 electron shells. Now if you look at the position of the magnesium atom in the periodic table, you will see that it is in group 2 and period 3. The group that an element is placed in the periodic table corresponds to the number of electrons in its outer or valency shell, and the period an element is placed in depends on the number of electron shells present in the atom. So in the case of magnesium, it has 2 electrons in its last shell, so it will be in group 2, and it has 3 electron shells, and hence it is found in group 2 and period 3 of the periodic table. As another example, consider the element neon, which has an atomic number of 10. And so an atom of neon will have 10 protons inside its nucleus and 10 electrons in the electron shells or energy levels. Since it has 10 electrons, it will have an electron arrangement of 2-8. It will have 2 electrons in its first shell and 8 electrons in its outer shell. This means it will be in group 8 or group 0 of the periodic table, and since the neon atom has 2 electron shells, it will be found in period 2 of the periodic table. As another example, consider the element potassium, which is an alkali metal in group 1 of the periodic table. Now potassium has an atomic number of 19, meaning it will have 19 protons in its nucleus and 19 electrons in the electron shells or energy levels. Having 19 electrons means its electron arrangement will be 2, 8, 8, 1. The first 3 electron shells are all full, and there is 1 electron present in its outer shell. Having 1 electron in its outer shell means that potassium will be in group 1 of the periodic table, and having 4 shells or 4 energy levels means it will be in period 4 of the periodic table. As a final example, consider nitrogen, which has an atomic number of 7, and so it will have 7 protons in its nucleus and 7 electrons in its shells. Its electron arrangement will be 2, 5, and having 5 electrons in its outer shell means it will be in group 5 of the periodic table, and having only 2 shells means it will be in period 2 of the periodic table. Hi, thanks for watching. If you found this video helpful or would simply like more information, then why not visit the website that accompanies these videos? The links are in the description below. If you enjoyed the video, then please consider liking and subscribing. Thank you.